Hello, my name is Konstantinos Voutetakis and I'm biologist bioinformatician at the Institute of Chemical Biology at the National Hellenic Research Foundation and member of e-NIOS bioinformatics spin-off company. This video is a short introduction to Galaxy web platform. But what is Galaxy? Galaxy is an open-source, web-based platform for data analysis. It's easy to use and completely free for everyone. It offers over 8,000 user-friendly analysis tools and is widely used. It currently has over 10,000 publications. It's developed by Penn State, Johns Hopkins, Oregon Health and Science University, and Cleveland Clinic, with substantial outside contributions. But what are the core values of Galaxy? Why use Galaxy? Because it provides accessible, reproducible, and transparent research. Data analysis can be very complex, and it often requires specialized programming knowledge or command line skills. But Galaxy makes this a lot easier by providing a graphical user interface to popular data analysis tools. Galaxy is also a web-based platform. This means you don't have to install anything, just open your browser and navigate to Galaxy. It keeps track of all analysis details, including the used tools and versions, the defined parameters of each step, enabling researchers to repeat a complete computational analysis, to share their analysis, and to publish their findings with all technical information. Finally, Galaxy supports many different scientific domains, such as bioinformatics, chemistry, ecology, climate science, and others. There are three main Galaxy servers: Galaxy Main, Galaxy Europe, and Galaxy Australia. These three galaxies have the biggest teams behind them and offer the most tools and resources. You can register an account for free on any of these servers. In addition, there are many smaller Galaxy servers to choose from. Many of these are domain-specific. For example, Galaxy Proteomics focuses on proteomics tools and workflows, while Galaxy Genomics focuses on genomics. The European Galaxy instance provides access to a huge compute and storage resource without any charge. Provides access to more than 2,500 different well-documented and constantly maintained scientific tools, allows for 250 gigabytes storage capacity per user, and 500 gigabytes storage capacity for Elixir members. You can freely register for an account, and it gives you access to a collection of tutorials developed and maintained by the worldwide Galaxy community. At the bottom of the slide, you can find also a leading publication for data analysis training for biology. This is an image of Galaxy Europe, located at usegalaxy.eu. The Galaxy user interface consists of three main panels that outline here with three different colors. The blue one includes the Toolkit panel on the left with all available tools, the red that includes the Viewing panel in the middle, where you will run your analysis tools by setting the appropriate parameters and view your data and results, and the green that includes the History panel on the right, which is a full record of your analysis history with your uploaded data. Of course, the first time you use Galaxy, there will be no files in your History panel. If you click on Login or Register, you will be taken to Login page. Here, you can register by creating a Galaxy account just with your email address and a password. In case you are an authorized member of Elixir network, you can also log in with the credentials of Elixir platform just by clicking here on Elixir login. The top taskbar of Galaxy user homepage is a menu with links to different pages. Specifically, the Analyze Data link goes you back to the homepage. The Workflow menu gives you access to existing workflows, or you can create a new workflow using the editable diagrammatic pipeline known as Workflow Editor. The Visualize button enables for new visualizations and launch interactive environments. The Share Data menu gives you access to data libraries, histories, workflows, visualizations, and pages shared with you. The Help menu includes links to Galaxy Help Forum, to Galaxy Community Hub, and to interactive training tools. The User menu includes connections to your preferences and saved histories, datasets, pages, and visualizations. And the last two icons here correspond to the Galaxy training material with a collection of tutorials developed and maintained by the worldwide Galaxy community. And the other icon here denotes the Scratchbook. You can activate the Scratchbook feature by clicking on the icon. It will toggle yellow. If you now create a visualization, like a chart, trackster, etc., the visualization will open in a resizable and trackable window. Using this feature, you can visualize multiple visualizations at the same time. The first step of an analysis is to get your data into Galaxy. This can be done in several ways. You can upload files from your computer by pressing on Choose Local File in the form displayed after clicking on this icon at the top of the tool panel, or you can enter a URL in this box, which is displayed after clicking on Paste Fetch Data button, and Galaxy will download the data for you. In case of large files, larger than 100 megabytes, it's recommended to upload data from Galaxy FTP server using an FTP client. Furthermore, Galaxy can import data directly from many public online repositories, such as UCSC browser, Ensemble browser, NCBI, EBI, specialized databases like Flamine, Wormbase, MouseMine, and many more by choosing the database of your interest from the Get Data menu of tools. Let's make a try to upload into our empty history a truncated version of a FASTQ file from a sequencing experiment by pasting in the address of the file, which is stored in Zenodo platform. Click Start, and when the download will has been completed, click on Close button. After this, you will see your first history item in Galaxy's history panel on the right. It will go through the GRE, which is the preparing, the queued state, and yellow, which is the running state, to become green, which is the successful upload. Galaxy tools only accept input datasets with the appropriate data types, while the data type of datasets produced by Galaxy tools are assigned by the tool. When you upload data, Galaxy will try to auto-detect the format of the data, but can sometimes get it wrong, so you may need to correct it later. Then, you can click on Edit Attributes and choose the Data Type menu to fix a wrongly assigned data type. By clicking on Edit Attributes, you can also choose convert formats to create a new dataset using a tool that converts the original dataset in the new format. New data types can be added to the Galaxy code base if missing. All files you upload will appear in your history panel on the right of Galaxy user interface. There are three buttons on each dataset in your history. The eye icon next to the file name lets you look at the file content as preview. This will show up in the middle panel of Galaxy. The pencil icon allows you to edit the attributes of the file. For example, you can change the file name here. The cross icon lets you delete the dataset from your history. You can also click on the dataset to expand it. This will show more information and more options in the history panel, such as to download this file to your computer, to view details about the dataset, the job executed and the tool parameters used, to visualize the file data, or to get help about the tool generating this file. In order to name your history, click on History Name, which by default is Unnamed History, and type in a new name, for example, My Analysis. Press Enter on your keyboard to save it, and you will see that the name of history has been changed. After your data is uploaded, you are ready to run tools. You can find tools by exploring the tool list on the left panel of Galaxy user interface. If you already know the name of the tool you want to use, you can enter this in the search box at the top of the tool panel, or you can use a word key to search for this tool. If you have found a tool you like, you can add it to your favorites by clicking the star here at the top of the tool in the central panel. And this tool can be easily found by viewing your already favorite tools after clicking on the star at the top of Toolbox. When you click on a tool, it will show up, as you can see here, in the middle panel. Here you can select your input files and set the parameters for the tool. Then you can hit the Execute button to start running the tool. If we go downwards with a sliding bar, there is also a brief description of the tool and its citation as well. Let's look now at the quality of the reads in the FASTQ file we just uploaded by running a well-known tool for the estimation of sequence quality, the FastQC tool. You can click on it and you can click on it and select as sort read data from your current history, the FASTQ file we uploaded, and click Execute with any change in the other parameters. This tool will run and two output files will appear at the top of your history panel above the input FASTQ file. Please note that Galaxy has given these files names according to both the tool name, which was the FastQC, and the dataset, data1, that it used. The name data1 means the dataset number 1 in Galaxy's current history, which is our FASTQ file. If you click on the second output file, FastQCon data1 webpage, you will have a look at the contents of this output file in the main Galaxy panel in the center of the page. You will see that these output files go through various states. When a dataset is green, it means it's waiting to run. When it turns orange, it means the tool is running. And when the tool is finished, the outputs will turn green if the tool runs successfully. You can then click on the history item to get more information and options. For example, you can download the file to your computer, you can get information about tool run, you can reload the tool with the same parameters, or you can visualize your data to get help about the tool. If there was a problem with the tool, it will turn red, generating an error message with an extended error report that you can submit to Galaxy community for troubleshooting. Galaxy also has many options to visualize your datasets. Depending on the data type, there will be different visualization options. Galaxy data types know what tools can be used to visualize the datasets. For example, sequencing data has a button for visualizing in the Integrative Genomics Viewer, the well-known IGV viewer. Tabular data will prompt you to build charts of different types, such as bar plots, box plots, pie charts, scatter plots, etc. Protein data can be seen in a 3D viewer, such as the PV protein or an GL viewer. RNA secondary structure can be seen in RNA structure viewer. The multiple sequence alignment viewer is a modular reusable component to visualize large multiple sequence alignments interactively on the web, and many other visualization tools for various types of data analysis. The other option of visualize menu is interactive environments. Galaxy Interactive Environments launch embedded Dockerized versions of popular data analysis suites such as Jupyter and RStudio right from within Galaxy. They allow you to dynamically interact with your data right on the server. When you want to start a new analysis, you can create a new history using the plus icon at the top of the history panel. You can have as many histories as you want, and you can easily switch back and forth between histories with the View All Histories icon and the switch to button in the view of all histories. You can also drag and drop datasets between histories. However, copying datasets between histories does not affect your quota. Only a single copy of the file is stored on disk because datasets are never modified after creation. Please note that giving your histories good names will help you to keep track of your different analyses. At any time, of course, you can go back into your analysis window by clicking on Analyze Data in the top panel. Another very useful aspect of running your data analysis in Galaxy is the workflow construction capability. This means you perform the analysis manually once and they can easily repeat it on different input data. Workflows let you run full end-to-end analysis very easily, and there are multiple ways to create a workflow. You can extract this automatically from your history just by clicking on the gear on the gear icon at the top of the history panel and choose Extract Workflow from the History Options menu. You can also build workflows by hand using the workflow editor as depicted in the center of the slide. The tools can be viewed as tiny Lego pieces. Each one solves a specific problem, and they can be combined together to build complex analysis pipelines. Finally, another option is to import a workflow of somebody else who has shared his or her workflow with you. Here are a few workflow generation benefits you can count on. You can rerun the same analysis on different input datasets by reducing the manual entry and request handling. You can change the parameters for one or more tools before you rerun a similar analysis. You can make use of the workflow job scheduling so as jobs are submitted as their inputs are ready, so you do not waste time to wait. It gives you also the possibility to create sub-workflows inside another workflows. And you can also share your workflows either for publication or with your colleagues and with the Galaxy community in general. Everything you do in Galaxy can be shared. You can share your history, your workflow, or your visualizations. There are different ways to share your work. You can either share it with specific Galaxy users directly by Galaxy account email addresses on the same instance, or you can get a share web link that you can send to anybody. If you publish your work, it will be visible to everybody from the shared data menu. If you get stuck with all this presented Galaxy stuff, there are a few ways to get help. You can ask your questions on the help forum. You can watch the Galaxy training material either by videos and slides or by hands-on exercises. Or you can chat with Galaxy community on Gitter, which is a developer-oriented chat room with 1,460 contributors. Well done! Your short tour to Galaxy platform has just been completed. You got familiar with what is Galaxy, why we use Galaxy, how we use Galaxy, and how we can become members of Galaxy community. Additional tutorials are also available for a more in-depth introduction to Galaxy's features. And as closing remarks, keep in your mind that Galaxy interface is a user-friendly computational workbench on your web browser. Galaxy allows accessible, reproducible, and collaborative biomedical research. Galaxy users are able to share and publish their exact analysis histories, results, workflows, and visualizations directly over the web, enabling transparency of computational research efforts and artifacts. Galaxy has grown into a thriving global ecosystem supported by a vibrant community of biomedical researchers, tool developers, and system engineers. And Galaxy has a huge and active user community. Thank you for watching this video. If you have any questions or need further information, please feel free to contact me at my email address. Of course, you can follow us on our official social media accounts. And do not forget, Galaxy is a free, public, internet accessible resource for everyone, and it's worth trying.